Alright, so let's get going. So we've talked a lot about exponentials, we've talked a lot about logarithms. What we're going to do today is we're going to learn to solve them. Yay! Alright, now the good news is there's two ways to do this. One of them involves a shortcut. Ooh. The other one is just, it's just what it is, alright? So I'm going to teach you two ways to solve those, and then I even made you this kind of little, I handed out already, review guide that hopefully will help you out if you get confused. Alright, so let's go ahead and let's get started with this. You already filled out your power chart, right? As much as you could. You guys should be really good with squares, but one thing that you're not as good at is your cubes and your fourth powers. Just make sure you fill that out at some point. We're going to be using that for this very first shortcut. Let me talk to you about it, okay? So if we're trying to solve an exponential, the shortcut is if I have an exponential set equal to an exponential, then you can set the exponents equal to each other if the bases are the same. So what do I mean by that? Well, I've got 2 to the 2x equals 2 to the 6. I have an exponential set equal to an exponential and the bases are the same. What does that mean I can do with the 2x and the 6? It means we can set them equal to each other. Which, what does that mean? How would you solve that, guys? And you get x is 3, right? Woohoo! Hey, that was easy, right? Yes, I told you you'd like the shortcuts. So, let me kind of back up again. Here's your formula. If b to the y equals b to the x, then y equals x. So this should make sense. If I have 3 to the third, no, let's do a different number. 3 squared is equal to 3 to the x. What does that mean x is going to be equal to? Just 2, right? Alright, that's in its simplest way. This is like the easiest problem you can ask for. But now, we're going to make it a little bit trickier and make it look like it's not a shortcut problem. I'm going to say 4 to the x equals 16. Now, are the bases the same there? No. But this is why I had you fill out a powers chart. Could I represent 16 as 4 raised to a power? And you'd say, yes. Hiram, what would that be? So I'm going to rewrite this as 4 to the x is equal to 4 squared. Now do we have the bases are the same? Yep, so then we set the exponents equal and we get x is 2. Yes. Got it. Okay, if you have questions, stop me. Let's go to number 3. Now on this one it's a bit tricky because I've got 16 raised to the negative p minus 1 and 64 raised to the p minus 2. Obviously 16 and 64 aren't the same. But what you need to be thinking is, what number could I raise to a power that gives me 16, and then it also gives me 64? So I want you to think on that for a second. Any guesses out there? What number could I raise to 16 and 64? Okay, shout it out. You think say no? 4. How so? How would you get 16 and 64? Go ahead, Mikkel. Awesome. Do you guys agree with that? Okay, cool. So what I'm going to do is I'm going to replace 16 with 4 squared. I'm going to kind of do that in parentheses here because it's still being raised to the negative p minus 1, okay? But then I'm going to replace the 64 with 4 cubed. And that's going to be raised to the p minus 2. So now, do we have a common base? Yes, it would be this 4. Okay? So now, what do we do with this exponents? We have 2 powers. When we have a power to a power, what do? They add, subtract, multiply, divide. They multiply. Good job. So I'm going to show a little note here. I actually have to distribute the 2 to both of those and the 3 to both of those. So what I'm going to have here is I'm going to have 4 to the negative 2p minus 2 is equal to 4 to the 3p minus 6. Make sure you distribute to both terms. Alright, so now that I've got the common base of 4, what do we do? We'll set the exponents equal to each other. So I'm just going to take those and drop that down here. And say, all right, negative 2p minus 2 is equal to 3p minus 6. And then let's get you guys helping out a little bit more here. I want to solve that, so let's just send this one to Brandon and Aya. How would you go about solving this, Brandon? Let's do that. Okay. So when I do that, I get negative 2 is equal to 5p minus 6. So that's going to give me 4 is equal to 5p. So we'd get p is 4/5. Well, that's not what I wanted, right? Okay. Now, it'd be nice if it always worked out that it would turn into a number that's not a fraction, but it sometimes will. How could I check to make sure that I got this right? I could go back to the beginning and plug it in negative 4/5, or in other words, 0.8 for p. And it plug it in on the left, and then I plug it in on the right, and it should give me the same thing. Okay, cool? Cool. Do you have any questions on that? There's the rest of the word if you can see it. Okay, so then 7, I'm going to give you a 30-second head start. And what I want you to do is to say, what number could I raise to a power to give you 36, and then raise to a different power that would also give me 1 over 216. So turn to your neighbor, brainstorm, and see if you can come up with that. I'll give you 30 seconds. All right, let's bring it back in 3, 2, 1. Any volunteers who thinks they know what they're doing here? Want to share? Don't be scared. Go ahead, Hiram. What are you thinking?
So 6 to the negative 3 is 1 over 216.
Awesome.
And then 6 squared is 36.
All right. Were you guys able to come up with that? I heard people whispering it. They're just too shy to get it. Yes, good. So 6 to the third power is 216. So if I wanted 1 over 216, I just make it 6 to the negative third. Okay? And then I'm going to have that 2. Okay, we'll stick in here with you, Hiram. What about, what's going to be my next step here?
So multiply negative 3 by x minus 3.
Awesome. Let's write that out. So this will be 6 to the negative 3x plus 9 is equal to 6 squared. Okay, do we have it? So it's an exponential set equal to an exponential with a common base. Yes, so then we can just set the exponent equal to the exponent. So let's say negative 3x plus 9 is equal to 2. And then now it's just down to some easy algebra. Let's send this to Kimberly. How would you use some easy algebra here to solve for x? Oh, sorry. I'm trying to erase it, right? Okay, so it's minus 9. That's negative 3x equals negative 7. Keep on going. So I get x is a positive 7/3. Is that what you're saying, Kimberly?
Yeah.
Awesome. And if you want to check it, you plug it in. Should give you the same thing on the left and same thing on the right. We're kind of going a little fast today because we got to get through a lot. So I'm going to let you do that on your own. And there you go. This is your exponential shortcut. So if you're trying to solve an exponential equation, and you can make it so both sides are an exponential with a common base, then this is how you solve it. Just set the exponents equal and go from there. Do you have any questions on this page before I move on? Once. Twice. Then, alright, let's go to the next page here. Okay. What if you can't do the shortcut? Then here's what you're going to do. We're going to follow these 3 steps, and this is actually going to be the same 3 steps for solving a logarithm. It's just opposite. Okay, so if we cannot use the shortcut method, then we're going to use what's called the rewrite method. Number 1, you're going to isolate the exponential. What does the word isolate mean, guys? Simplify it so that nothing is adding, subtracting, multiplying, or dividing by it. We want to make it so it's all alone. Okay? Then you're going to rewrite it as a logarithm. How do we get from an exponential to a logarithm? Remember, it's, what are we thinking? All about that base. All right. Then we're going to solve and check it. Let's do an easy problem. Oh, I think these are actually, hold on. I think some of these problems are from your assignment, and you were like, where are these numbers for? Well, I think I was doing your homework for you, and I just forgot to hand out your homework. So let's hand out your homework. I'm pretty sure I was supposed to do that, and I forgot. Yeah, that's right. You can just transfer them. So, hey, that's cool too. I'm going to be doing some of the examples from your assignment, so that's less work for you. You're welcome. Okay, so yeah, so on the last page, I already did number 3 and 7 for you. Transfer it over later. Don't worry about that right now. Let's go and do this. Okay, so we're doing number 9 on your assignment. So you could do this on the notes or on number 9. Either way is good. Okay, but what we're going to do is we want to solve this. Now, could I think of a number that I could raise to a power to give me 20 and raise to a power and give me 65? Yeah, nothing comes to mind. Alright, so what am I going to do? Well, we're going to go through these 3 steps: isolate, rewrite, solve, and check. So, let's, how would I rewrite this exponential as a logarithm? Turn to your neighbor, rewrite this as a log, and then I'm calling on someone in 15 seconds. Go. Alright, time is up. We're sending this to Tao. How did you rewrite this as a log? That would be the other way around. This one's Megan Trainer. All about that base. There we go. So, what about that base? What is the base? Yeah, so when I'm looking up at the exponential, what is the base of the exponent? So it'd be 20, so that 20 goes down into the base of the logarithm, all about that base. And then what will go inside of the base? Good job. Because we're solving this for the exponent, so it's going to be equal to b. And, hey, check that out. It's already solved. b is, log base 20 is 65. Well, what is that? Put it in your calculator, math up, and then you got it. But I'm going to leave it like that. When you put it in your calculator, it'll give you a decimal approximation, which isn't exactly the right answer. It approximates it, so this is the most precise one. But I guess it's good. Well, most of you guys don't have a calculator, so we're not going to worry about it. You know what buttons to push, right? What buttons? Math up. All right, cool. Let's go to 15 now, okay? So on 15, we have 7 to the x plus 4.4 plus 4 equals 34. Okay, so number 1, isolate the exponential. Guys, what is the exponential here? Yeah, it's this guy, right? Is it alone? What is bothering it? How do we get rid of that 4? Alright, so it wants to be alone. So you gotta get rid of that. So then I get 7 to the x plus 4.4. That's going to be equal to 30. Now sometimes people say, well, it's not alone yet, it's still got this exponent. If it's in the exponent, it's okay, it's part of the exponential, okay? But nothing is adding, subtracting, multiplying, or dividing the exponential. Now, let's think, could I use a shortcut here? Is there a number I could raise to a power to give me 7 and also give me 30? No. So then what I need to do here is rewrite it. All about that base. How are we going to do that? Let's send this one to Izzy. I want to write it as a log. Izzy, what's going to be the base of that log? Awesome. What's going to go inside the parentheses here? Great. And what will that be equal to? Great job, Izzy. So there we go. So we isolated, check, and now we just rewrote it. And then now it's not solved for all the way. I want to solve and check, but we're so dang close. What do I just have to do? I want to get x alone. What was that, huh? How do I do that? There we go. So I'm going to minus 4.4 on both sides. So I'm going to get log base 7 of 30. And then after I find that, I'm going to take off 4.4. That's going to be equal to x. Now that's the exact answer. If you wanted a decimal approximation, you do math up, and then you'd solve it from there. Okay? Cool, cool, cool. That's how you do the rewrite method. So if you're solving an exponential, first try the shortcut. If that doesn't work, then you're going to try this. Okay? You have any questions on this? Okay, now let's go. Do you guys have that handout that I gave at the very beginning? Can I borrow this, Kimberly? So notice on this first page, it has a summary of that, and it has the exponential shortcut. Then as a log shortcut, we're going to go over that just next. Then on the back, it gives the example of the exponential rewrite method and then the logarithm rewrite method. So there's a guide for you to look at when you're doing your homework just to make sure you're all on the same page. And notice, thumbs up, always make sure you give yourself some love for doing it right. Okay, logarithmic shortcut. Okay, if I have a log set equal to a log and the bases are the same, then you set the arguments equal to each other. I just set x equal to 3, and there's my answer. Okay? So that's the logarithm shortcut. If you have a log set equal to a log and the bases are the same, set the exponents equal. In this example, I don't see any bases. What does that mean, the bases? Can we call that a common log? Good job, guys. All right, so let's go to 17 to begin with, and then we'll go to 19, okay? So we're starting over here on 17. Do we have a log set equal to a log? Great. Are the bases the same? I'm not seeing a base. What does that mean it is? And it's a common log. So then, yeah, I have a log set equal to a log, so what do?